In this problem, we are asked to use the Kirchhoff's laws to state relationships of the following. Okay, I's, I1, I2, I3. This one is E2R, I2, and I3. And the last one is E1, E2R, I1, and I2 in specific loops. Okay, let's start off with the very first one. So between currents I1, I2, and I3, what is their relationship? If you look at our image here, this is the junction where they most likely split. Okay, so current would flow here, and eventually split out there. So it's safe to say that the relationship is I3 equals to I1 plus I2. Okay, so if you added up I1 and I2, you will get I3. If you try to break it down, you will get I1 and I2. All right, how about E2, R, I2, and I3 in loop BCXYB? So that's BCXY going back there. Okay, so here, if you look at it, okay, let me just clear this first. Our power supply here is coming from this side, so that would go that direction. Okay, so what would be the relationship? So whenever you're dealing in a loop, we use the second law of Kirchhoff, where an EMF or the sum of EMF is equals to the sum of the individual PDs on that certain loop. So in this case, you will have your E2 equals to I2R plus I3R. Okay, they're all moving harmoniously with each other, same direction, no opposing of the other parts. Okay, how about loop A, B, C, X, Y, and Z? So that's this loop here, the bigger area. Okay, so we can start off with E1. Notice that it's E1 moving in this direction. Okay, that's E1. Now, how about E2? E2 is actually in opposite direction. It should be minus equals to the individual PDs. So you'll have your R's. So you'll have your 2R I1 okay, minus the I2R because it's opposing the direction. The movement is this manner. This one is opposing the direction. So it becomes negative. So this is how you state relationships under the Kirchhoff's laws.